Hello, let's do the New York Times Hard Sudoku for December 11th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we're going to start with this 7 and 9. So we're looking for buddies. So this 7 has a buddy over here. Buddies in the band. If you find it in the band, you don't need to look anywhere else until you start marking. So 7, one of these two, I looked down to see if there are any 7s. There weren't. The 9, there's no buddies in the band, so we want to look for buddies below the bands. So we have this 9 here, but they do not work together well enough. We've only reduced it to 3 places, and they're not all in a line, so we're not going to mark that. We're also going to do the 2, 4, and 6 here. So the 2 doesn't really have any buddies. The 4 has this buddy here, so that puts a 4 in one of these 2 cells. We will mark that. Over here, no buddies. And then the 6 does have this buddy. Oh, and this one as well. So that places 6 in this box. Now this 6 has a buddy here. Puts a 6 in one of these 2 cells. All right. So that was the 6. Now we're going to look at the 1, 3, 5. We did the 7. So the 1 does not have any buddies. The 3 does have this buddy here, but they don't really work well together. And then the 5. Okay, we do have 2 5s looking up into here. And then we also have this 5 looking in. That places the 5. Follow up on that, these 2 5s. Put a 5 in one of these 2. All right, so that was looking at every given. I'm noticing this cell here is not the 4 or 6 in addition to 1, 3, 5, 7. So if we count, it's not 6 digits, at least. I also see in the row that it's not the 2. So this is going to be quite limited. It's going to be down to 2 digits. It's not the 1, 2, 3, 4, 5, 6, 7. So it's only 8, 9. Very nice. This one's also not 2. So it's not 2 or 6. So that means it's going to be, let's see, 1, 2, 3. It's going to be 4, 8, 9. That's what's left there. Okay. I'm looking at how this cell's not 2 or 4, in addition to the 1, 6, 7. 2, 4, 5. Yeah, this is worth marking. It's not 1, 2. It could be 3. Could not be 4, 5, 6, 7. Could be 8, 9. So 8 and 9 in general are just not well known in this top band. Okay. I think that's all I'm going to get out of that. Let's actually move on to the next band, starting with the 5 here. I always start with the box with the fewest givens. So we have these 2 5s here. This 5 looks down, puts a 5 here. We can follow up vertically there to get this 5 in one of these 2. Okay, so I did the 5. We can do the 1 and the 4. So the 1 does not have any buddies. The 4 has this one that doesn't do much. Okay. Yeah, that's all we got out of that. Now we have the 6, 8, and 9 that we haven't looked at. So 6s, we do have 2 6s looking in here along with this 6, putting a 6 in one of these 2 cells. Can't get much out of that. The 8 and the 9. Okay, we don't know much about them. These 8s aren't quite good enough. These 9s also not good enough. Okay, we do have 2 9s here that I'll take care of. It's a 9, one of these 2. All right, I think that's all we get out of this band. There's not anything else real juicy to look at that I can tell. Okay, so let's do this final band here. So we have the 3 and the 6. So the 3, we do have 2 3s. That does place the 3 here. That's going to remove the 3 from here, giving us an 8, 9 pair. The best time to find a pair is when you mark it. So this was 3, 8, 9. I removed the 3, saw it was down to 8, 9. So I looked to see if it paired with anything. And we immediately see the 8, 9 pair. Now this is called a naked pair, right? It's not. There's naked pairs and hidden pairs. I think a lot of my viewers actually understand the hidden pair better than the naked pair. But the naked pair is basically saying, well, this cell can only be 8 or 9, and this cell can only be 8 or 9. And since they have to be different digits, since they share the same row, one will be 8 and one will be 9, removing 8 and 9 from the rest of the row. So the consequence of a naked technique, like a naked pair, is that it affects the rows, columns, and boxes that it appears in. So this only appears in this row, not a column or box. So it removes 8 and 9 from the rest of this row. So this can't be 8 or 9, so it must be a 4. These 2 4s now look in here, putting a 4 in one of these 2. We also know this is going to be a pair. It's the 3, 5. This 3 tells us that's 3, that's 5. Very nice. Okay. What else do we get out of that? We do have these two threes. This 3 looks up. That places the 3, which then also places the 7 based on our corner mark. The rest of this box is a 1, 8, 9. The 1's one of these two. So that points in, telling us 1's one of these two. This row is down to 4 digits. I always like to look when it's down to 4. We need the 1, 2, 6, 8. We know neither of these are 6, so these are 1, 2, 8. Neither of these are 1, so these are 2, 6, 8. Oh, it's not an 8. In fact, this 8 looking in puts an 8 in one of these two cells. That's going to point down along with this 8, putting an 8 in one of these two cells. This column has been reduced to 4 digits as well. We need the 2, 6, 8, 9. We know these aren't 8. In fact, this isn't 6, 8, or 9, so this has to be the 2. Can't be anything else. And then now we're down to 6, 8, 9. I'm seeing quite a bit that can be removed. That's not 8, that's not 9, that's not 6. Okay. 2, 6, 8, 9. This one's not 6, so this is 2, 8, 9. It's not an 8 either. This whole box is 1, 2, 4, 8. I don't, oh, the 1's point in, right? So this is only 2, 4, 8. All right, so I just have this whole band just marked up now. I got this 4. I'm going to see if I can follow up on any of these. These two 4s look down. I got the 3, 5, and 7. So the 3s look in here, putting a 3 in one of these two. We got the 5. 5s are done. We got the 7. Unfortunately, I don't see anything to do with 7. We've got the 3, 5, and 6 here. So the 2 3s look in here. That actually places the 3 in this box, which places the 3 in this box. Which then places the 3 in this box because of these 3s looking in and this 3 looking down. We are done with 3s. We have all of them. Cool. We also have the 5 and the 6. So these two 5s do look down. This 5 helps, putting a 5 in one of these two. And then the 6s are taken care of. Okay. This box has now been reduced to 4 digits since we placed that 3. We need the 1, 2, 4, 7. This one's not 1, so it's 2, 4, 7. This one's not 4, so this is 1, 2, 7. Surprisingly not limited, though. This box is also down to 4 digits. We need the 1, 4, 7, 8. So we see that we have this 4 looking down, putting a 4 in one of these two. I'm seeing two things. One is these 4s point up. This 4 looks down. This 4 looks in. And it puts a 4 in one of these two cells. Now, with the overlapping 4 and 6 here, this is a hidden pair. So this was our naked pair, this 8, 9. Hidden pair is kind of the opposite side of the coin, where we're saying the 4 and the 6 have been limited to these two cells. So one of these cells will be 4 and one of them will be 6. And instead of affecting the rest of the row column box, although you can use it as a naked pair later, but the immediate effect is it removes everything else that could have been in these cells. So instead of saying this was down to only 4, 6, this was down to only 4, 6, what we said is the 4 and the 6 need to be placed in the box somewhere, and these are the only two places. So we better not put anything else in those cells. So that's a hidden pair. And so what we want to think about is what was removed from these two cells that might now be interesting to the row column or box. Well, the column's now down to 1, 8, 9, so we can just mark that. Now for the box, that means that 1, 8, and 9 were potentially removed from these cells. So like this 9 looking in and this 9 looking up. Now 9 can't be in this cell, and that puts 9 in one of these two cells. That 9 points left, giving us the 8, which gives us the 6, which resolves the 4 and 6. That 6 gives us the 9 here, resolving our 9 and 5. That can't be an 8 anymore. And then we get the 5 here. Okay. Just got a bunch of stuff, so give me a second here. So 1, 8, and 9. This just got filled with 4, 6. So we have the 9 looking in. What do we need? We need the 1, 2. I'm just looking for anything looking in that might be interesting. So 1, 2, 7, 8, 9. I don't really want to do anything with that yet. The rest of this row is 1, 2, 7, 9. This can't be 9, right? So this is 1, 2, 7. This can't be 2, so this is 1, 7, 9. I'm going to go back to, remember when I marked these 4s, I said I saw 2 things? Well, we just got a whole lot out of that. But before I forget, I also noticed that these 4s line up here. By lining up, I mean they're marked in 2 places, and these are marked in 2 places for these boxes, and they both ignore row 8. They both can't be in row 8. So the question we want to ask is, where does the 4 go in row 8? And the answer is only in one of these two cells. And that's going to do what's called claiming, because if the 4 is in one of these two cells for the row, they both happen to be in box 9, meaning the rest of box 9 cannot be a 4. And so now the question actually to ask is, where is the 4 in this column? Because we know this can't be a 4 anymore. This isn't a 4, and this isn't a 4. We actually place the 4 for the column. Even though there's another place in the box and another place in the row, the column has only one place. We need to place the 4 there for that reason. That leaves 2 digits left for this row. It is the 1 and the 7. The 7 tells us that's 1, that's 7. The rest of this box, we need a 2, 7, 8. Actually, let's follow up on this 1 first. Place the 1 here. And then these 2 ones, put up one of these 2. But I said 2, 7, 8. The 8 looks down. Putting an 8 in one of these 2 cells. That points in. Putting an 8 in one of these 2 cells. Actually, where's 8 in this box? That was something that I didn't notice. I didn't go through all of 1, 8, 9, apparently, well enough, because 8 is actually limited to exactly right here. This 8 looks in. And this 8 looks in. Okay, so that's our 8. And then that resolves the 8 in this box as well. There's so much to do here. The 7, here, this 8, this isn't 8. Basically, anywhere I look, I'm going to find something now. This can't be 9, so this is only 1, 7. In fact, we only have 1, 4, 7 left in general. This box has 1, 4, 6. Why does that feel weird to me? Anyway, neither of these are 1s, so that places the 1 here. And then this can't be a 6, so this is our 4, this is our 6. That resolves the 4 here. We get our 7 and our 1. That's not a 7, that's not a 1. So this is a 2, 7 pair and a 1, 9 pair. That means that's not 1 because of the 1, 9 pair. Placing the 1 in this box. Basically everywhere I look, there's something. This isn't 6 anymore. This affects the 2. That gives us the 6 and 8 and 9. Giving us the 9, 1, and 8. Giving us the 8. These are not 8s. This is an 8. All right, we get our 1 and 9 here. This column needs something. It needs a 7. Gives us 2 and 7. Gives us 4 and 2. Gives us the 4 and 2 here. All right. Here we need a 2, which goes there, and we need a 9. And then this box, we need a 7. We're down to 2 and 7. That's our 2, that's our 7, and we're done. All right. I think probably this naked 8, 9 pair and this hidden 4, 6 pair were the most important things, although it was fun to find these lined up 4s as well, giving us the 4 in one of these 2. Which actually, the follow-up from the 4 in one of these 2 was that 4 now in this column could only be right there. So that was really interesting. It's basically a double claiming situation. So the intersection of this row and this column forced the 4 to be there. Otherwise, it would not be able to be in one of the 2 row or columns. Cool. Well, let me know how you did on this one. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.